Hello, intermediate algebra friends. Welcome to section 9.6, solving rational equations. So we are going to combine our 9.1 and our 9.3, throw in a little 9.2, and here we are, 9.6. Yes, we did skip over 9.4 and 9.5, so you are not missing anything. So today we are solving rational equations. The last three sections we talked about, we were just given an expression and we did what we were told with that expression. We either simplified it, we multiplied, we divided, we added, or we subtracted. And we weren't looking for values of x because we weren't given an equation. Today we're solving rational equations, so we're going to have combinations of rational expressions that equal some other rational expression, and we're going to be solving for the value of x. Okay guys, so process here. When we're solving a rational equation, the goal is to get just one rational expression on each side of our equation. So we're not going to forget everything we've covered in the previous sections. If you notice, quite simply, 2x plus 1 over 3 plus x over 3 equals 7/3. Let me just rewrite the problem. Well, we can combine these two rational expressions on the left-hand side. They have a common denominator, so we are going to combine them and call that 2x plus 1 plus x all over 3. So we add the numerators and we keep the common denominator. You could have just gone right and called that 3x plus 1 if you're feeling comfortable. You could have just added the numerators, came up with 3x plus 1, kept the common denominator, 7/3. All right, so now we're at this point. We have a rational expression on the left, we have one rational expression on the right, and they have a common denominator of 3. So the trick here is to eliminate the denominator of the rational expressions. Notice if we multiply both sides by that common denominator of 3, 3 times 3x plus 1 over 3 equals 7/3 times 3. We can just cancel these guys out. So 3 times something divided by 3, the multiplying by 3 and the dividing by 3 cancel. 7 divided by 3 times 3, those just cancel. We can legit just set the numerators equal. So check that out. We get the simple linear equation. We started with a more complicated rational expression. We converted it into a linear equation by combining the rational expressions on the left, eliminating the denominator, and now we can just solve this. We're going to subtract 1, and we get 3x equals 6, divide by 3, and we get x equals 2. All right, now we have to be really careful here. With rational expressions, you have to be really careful with your solution. Remember back in chapter 7, when we solved radical equations, we got solutions that sometimes worked in the original equation and sometimes didn't. The ones that solved the equation but didn't work in the original equation were extraneous solutions. So we have to look for extraneous solutions also with rational equations. Although this is a little bit simpler, we just ask ourselves, is 2 a restricted value of any of the rational expressions that we started with? So remember, a rational expression has an excluded value if that value makes the denominator 0. Here we have no variable in the denominator. We started out with a pretty basic problem. 3, 3, and 3, the denominator will never be 0, so this is not a restricted value. So therefore, we can conclude that the solution of this equation is, the only solution is x equals 2. Now you can go back in the original and we can check. We're not going to check all of them, but you can always check. So here's my original equation, and I'm going to put 2 into the original equation. 2 times 2 plus 1 all over 3 plus 2 over 3, and does that equal 7/3? If this is not a restricted equation and we did our math correctly, then this answer will always work. So now let's do 2 times 2 is 4 plus 1, 5/3 plus 2/3. Does that equal 7/3? Well, 5/3 and 2/3 is 5 plus 2, which is 7/3. 7/3 equals 7/3, so it does work. So there is our solution. All right, so let's keep practicing. The only way to get good at this. All right. Let's solve 2x plus 1 over 3, but this time I have x over 5 instead of x over 3. So I threw a little loop into this by changing the second denominator. All right, our goal is to get fractions on both sides with common denominator. All right, so the common denominator of 3 and 5, well, 3 and 5 are both prime. This is just 3 times 1, and that's 5 times 1. So this is missing the factor of 5. That's missing the factor of 3. So I'm going to just write this down, 2x plus 3 plus x over 5 equals 7 over 3. So this denominator is missing the 5, so I'm going to introduce the 5 to this denominator, and in order to maintain the value of the fraction, I have to multiply both the numerator and the denominator by 5. So my common denominator, my least common denominator is going to be 15, so this one needs the 3. Now, it's in our best interest to get a common denominator all the way across the board. So here, all I need to do to get this denominator to be 15 on the right-hand side is to multiply the top and the bottom by 5. Now I'm going to distribute my numerator. It's going to be 10x plus 5 all over 15. And I said don't multiply out denominators. When it's constant, that's easy. If it's not constants, then we don't necessarily need to. Plus 3x over 15 equals 35 over 15. So now we have all our rational expressions in this equation with the same denominator. So now let's just get one rational equation on the left and one on the right. We already have one on the right, so let's just add these numerators and keep the common denominator. 10x plus 5 plus 3x is 13x plus 5. I got that by adding the 10x and the 3x all over 15 equals 35 over 15. So I have 13x plus 5 over 15 equals 35 over 15. So in order for this over 15 to equal this over 15, then our numerators just have to be equal. So the next line is just 13x plus 5 has to equal 35 because the denominators are the same. And the algebra here is multiplying both sides by their now common denominator. So if I multiply 15 by 13x plus 5 divided by 15, multiplying by 15 and then dividing by 15 cancels out. 35 divided by 15 times 15, these cancel out. So this reduces to just solving this little itty bitty linear equation. And now I'm going to solve for x. We solve for x by subtracting 5. And then we divide out the 13. So x is equal to 30 over 13. Now I'm going to go back up here, and I didn't mention this at first. Because my denominators are constants, there are no restricted value in either of these three expressions. Remember, the denominator of a fraction can never be 0. Numerators can, denominators can't. So this is not a restricted value because all three of our original expressions, the denominator will never be 0 because that's only 3, that's only 5, and that's only 3. So therefore, this is my solution. It's not a restricted value. So just make sure you check that. And this is my solution. 30 over 13. And if you're, up to the challenge, put 30 over 13 in there and actually check, show that this will work. All right, so let's take this up a notch. Let's throw some variables in the denominator. All right, so I have 2 over 5x squared equals 3 divided by 2x all over 1 over x. Now notice that all the constants are on the top and the denominators are on the denominators all contain the variable. So your goal is to get common denominator across the board. So the more you do, the more comfortable you will get with this. Equals, so 2 over 5x squared equals 3 over 2x minus 1 over x. So if you imagine factoring these, this is just 5 times x times x. Here we just have 2 times x, and here we have just x. So remember, our goal is to introduce what the denominator is missing that the other denominator has. Notice my first denominator has 5x and x. But this denominator has a 2 and this one doesn't. So this denominator needs the factor of 2. So I'm taking that 2 and introducing it over here, and I'm making this numerator 2. All right, so now this denominator has 4 factors. This denominator only has 2 factors. It has the 2 and the x. So here's the 2 and here's one of the x's, so it's missing the 5 and the x. So I'm going to throw 5 and x over here. So then I have to throw the 5 and the x in the top. Now this guy only has 1 factor in the denominator. Now both of these have a 2, a 5, and an x and an x. This only has an x, so it needs the 2, it needs the 5, and it needs the x. So this numerator needs the 2, the 5, and the x. So my common denominator is going to be 2 times 5 times x times x. Now, if these were factors that were binomial factors, I wouldn't multiply, but just for the sake of simplicity, the common factor here is 10x squared. And the new left numerator is just going to be 4, 2 times 2. And this equals my new denominator over here is 10x squared. And then it's going to be 15x in the middle numerator minus my common denominator 10x squared. And it's going to be 2 times 5 times x, which is 10x. So solving 2 over 5x squared equals 3 over 2x minus 1 over x is equivalent to solving 4 over 10x squared equals 15x over 10x squared minus 10x over 10x squared. So our goal is to get the least common denominator, and then we get one fraction on both sides of the equation. So we turn this subtraction into one fraction. When we subtract fractions, we keep their common denominator. 15x minus 10x is 5x's. Now, once we have one fraction equals the other fraction with that same common denominator, we can now eliminate the fraction by multiplying both sides by the common denominator. So here we're dividing 4 by 10x squared. To undo that, we multiply by 10x squared. So what we do to one side, we have to do to the other. 10x squared times 4 divided by 10x squared is just 4. 5 divided by 10x squared times 10x squared is just 5x. All right, so now I solve for x. I divide by 5. And I get x is equal to 4/5. All right, check. You have to ask yourself, is this a restricted value? Are we allowed to use this? Now remember, if you do the math correctly, your answer will be an answer to the original problem if you did the math correctly, as long as it's not a restricted value. If we go back up to the original problem, the only restricted value is x equals 0. So x cannot be 0 in the first fraction, x cannot be 0 in the second fraction, and x cannot be 0 in the third fraction. So the only restricted value is 0. So if we got 0 here, it would be a solution to the revised equation, but would not be a solution to the original equation. It would be extraneous. But it's not a restricted value. So therefore, my solution is x equals 4/5. So I challenge you to check this. Half of the battle in a check is checking it correctly, but this will work if you do the math correctly. All right, remember, if you're having a hard time with this, feel free to pause, rewind, watch the steps again. And if you're still struggling, put a little star next to it and zoom in. I'll be more than happy to go over any of these problems. All right. So here we're going to get a little more complicated. We're now going to have binomial expressions as well as monomial. So what we do first when we're looking to solve a rational equation means we have rational expressions and our unknown appears in one or more places in the rational expression. So first, we're going to factor all denominators. And our goal of factoring all denominators is to find the least common denominator. So this is just a single variable of x, so there's no factoring to be done. We're going to factor the middle denominator. It's a binomial expression. It's not the difference of squares or the difference of cubes, but don't forget 6.1, our very basic factoring, where we just factor out the greatest common factor, which would be x. So x squared minus 5x can be factored into x times x minus 5. And then our right denominator is also x times x minus 5. So notice the only factor is x and 1, obviously. And the left denominator, the middle denominator has both x and x minus 5. The right denominator has x and x minus 5. So next, we're going to introduce missing factors. So we're going to introduce the missing factors into respective denominators. Right, so we have 1 over just x plus 1 over x times the factor x minus 5. Now x minus 5 and the parentheses itself is a factor. So this has two factors, x and x minus 5. And the right denominator also has the factors x and x minus 5. So all that's missing from the very right fraction is the factor x minus 5. These both have two factors, x and x minus 5. So we're going to introduce the factor x minus 5 both into the numerator and the denominator, because by multiplying both the numerator and the denominator by x minus 5, we're multiplying by the equivalent of 1. So what this becomes, this new fraction on the left, is x minus 5 times 1, which is just x minus 5, x times x minus 5 plus x plus 1, x times x minus 5 equals 3x, x times x minus 5. This is a good place before we combine everything. Once we have our common denominator, so once we have our common denominator, let's determine the restricted values. So if we look here, our restricted values, what would make each of these denominators 0 would be 0 here, and then 5 for the second factor. So what this is telling us, when we proceed to finish solving this equation, if 0 or 5 are a solution to the revised equation, then they're not solutions to the original, because we are not allowed to put 0 or 5 in the original equation. So we'll worry about that when we get to the end. So just keep that in mind. Restricted values, x cannot be 0 or 5. All right, so now let's get one fraction on each side. Get a single rational expression on each side. So we have x minus 5 over the common denominator plus x plus 1 over the common denominator equals 3x. We already have 1 on this side, so this is all good to go. Leave denominators distributed. There's no need to multiply them out. So then I'm going to just create one numerator here. Right, so if I add something over x times x minus 5 plus something else over x times x minus 5, we keep the common denominator and we add the numerators. So it's x minus 5 plus x plus 1. So now let's clean this up. 2x minus 4 all over x times x minus 5 equals 3x over x minus 5. Woo! We're getting there. All right, once we're at this point where we have a single rational expression with a common denominator on both sides, let's eliminate the common denominator. so we have 2 times x minus 4, x times x minus 5 in the denominator equals 3x over x times x minus 5. So if something over x times x minus 5 equals something else over x times x minus 5, then really we could just set the numerators equal. 2x minus 4 must equal 3x. Algebraically, we get that by multiplying both sides by the common denominator. And if you're comfortable and want to just skip this step and set the numerators equal, because x times x minus 5 times 2x minus 4 divided by x times x minus 5, so we're multiplying, then we're dividing by the same thing, those just cancel out. So 2x minus 4 equals 3x. We're going to solve for x. I'm going to subtract 2x from both sides. I get negative 4 equals x. So x equals negative 4. And then check. Is your solution a restricted value? Well, our restricted values way back here. Where are they? Our restricted values are 0 and 5. Oh no. Oh, okay, phew. Thought I was running off. All right, so is your solution a restricted value? Nope. Our restricted values are 0 and 5. So therefore, that is a solution to the original equation. So therefore, your solution is x equals negative 4. Woohoo! That was fun. I'm going to move these up a little. There we go. Hopefully I didn't cut any off on you. All right, let's have another one. 3 divided by x minus 3 minus 18 over x squared minus 9 equals 5 over x plus 3. So first thing we're going to do is factor all denominators. 3 over x minus 3 minus 18. Now your chapter 6 factoring skills are going to come in handy. X squared minus 9. Think about that for a minute. What do you recognize? Hopefully you're saying the difference of squares. That's x squared minus 3 squared. So that's just 18 over x minus 3 and x plus 3. Oh, look how convenient. X minus 3 is the only factor in the left denominator. And this is 5 over the only factor, x plus 3. So let's identify our restricted values. What are our restricted values here? We can look at any of the denominators, 3 there, which also comes from that factor, and negative 3. All right, so you can do it now, you can do it after we combine. Doesn't matter, you're going to get the same result. All right, so now let's find the common denominator. All right, so 3 over x minus 3 minus 18 over x minus 3, so they share that. This one doesn't have the x plus 3 though. X plus 3, right? And that one has x plus 3 but doesn't have x minus 3. So notice this has 2 factors. These each have 1. This one has the x minus 3, so this one needs the x plus 3. So let's throw in x plus 3 on the top and the bottom. So the left denominator is x minus 3, x plus 3. Middle denominator, x minus 3, x plus 3. Right denominator has the x plus 3 but needs the x minus 3. Okay, there we go. That's our common denominator. Do not distribute. You can if you want to, but it's just wasting time. And when we get our final answer, we may need to simplify and cross off common factors at some point. So we just want to avoid that. So my new left numerator is 3x plus 9 all over x minus 3, x plus 3, minus 18. This one doesn't change at all. X minus 3, x plus 3 equals, now my right numerator, you have to distribute here because we're going to be solving for x, so we need to distribute to combine like terms in the numerator. 5x minus 15, x plus 3, which is x plus 3 times x minus 3 is the same thing because multiplication commutes. Now let's get one fraction on the left side of the equation. 3x plus 9 minus 18 will be 3x minus 9 all over x minus 3. x plus 3 equals 5x minus 15 all over x plus 3, x minus 3. Now we have one fraction on both sides of the equation. So we can just mentally imagine doing this. I should write it down to be proper, but you can even do this in your head now. We're going to multiply both sides by the common denominator, and I ran out of room. And then that will force us to cross this off. And we land up solving 3x minus 9 equals 5x minus 15, right? So now let's solve. I'm going to bring this over here, so let's subtract 5x from both sides. So we get negative 2x minus 9 equals negative 15. We're going to add 9. I'm going to keep plugging along. So then we get negative 2x equals 6. Negative 6, be careful, don't lose that negative 6, right? And let's divide by negative 2. X is equal to 3. Uh-oh. Look. So what this is telling us, if this equation has a solution, the only number that would work would be 3. But 3 is a restricted value. We can't put 3 into the original equation because 3 over 0 is impossible. It doesn't make sense. It's undefined. So this is a situation where we have a solution that's a restricted value. So our solution, x equals 3, is a restricted value. What does that mean? Thus, x equals 3 is called extraneous, extra. Remember, we came across those in chapter 7 with radical equations. Seeing this was our only option, the original problem has no solution. And you'll see this, problem as an option in ALEKS. One of the answers in ALEKS will say x equals, and it'll leave your little box, or it will have something you can check that will say no solution. So no solution. X equals 3 is not an answer. It does not work. Right? We still have a couple more to go. So I'm trying to get in all the little tricks here. All right, let's look at this guy. It looks simple, but often the simplest ones tend to be the trickiest ones. So let's rewrite this. We have 5 over just the factor x minus 2. Sometimes it's helpful to put them in parentheses so you can think of them as factors. 6 over x plus 2 equals, well, 2 doesn't look like a rational expression, but I'm going to express it as one just for to keep in mind that we have to treat these all like rational expressions. So the only factor here is x minus 2. The only factor here is x plus 2. And the only factor there is 1. So we really do have a 1 here, like you can always insert 1s. So what is the left denominator missing that the right one has? Well, the x plus 2. So this guy needs x plus 2. So I'm going to have 5. I'm going to give it the x plus 2. But don't forget, if you give it to the denominator, you have to give it to the numerator. Plus, well, this guy has the x plus 2 and the 1, but the 1's irrelevant. I just put it there to notice that they all have 1. And this middle fraction is missing the factor of x minus 2 that the left one has. So we give the middle fraction the x minus 2. And then we look at 2 over 1, and we notice that this denominator is missing both factors, x plus 2 and x minus 2. Don't forget to give it to the numerator. All right, so this simple problem got complicated pretty quickly. All right, so we have, now I'm going to actually determine the restricted values before I combine them. Restricted values, x cannot be 2 or negative 2. If we look at all our denominators, 2 and negative 2 would make the denominator 0. So whatever we get for a solution, if it's anything other than 2 or negative 2, it will solve the original equation. All right, let's distribute the numerators. 5x plus 10 all over the common denominator, x minus 2, x plus 2, plus 6x minus 12. Don't forget to distribute. That 6 is times the entire difference, x minus 2, so that turns into 6x minus 12. X plus 2, x minus 2. Remember, multiplication commutes, so those are the same denominator. And this all equals 2 times x plus 2, x minus 2, all over x plus 2 times x minus 2. Okay, now that we have common denominators across the board, we're going to get one rational expression on each side. This one's already 1. So now let's add these numerators on the left and keep the common denominator of x minus 2, x plus 2. It's going to be 11x minus 2 equals 2 times x plus 2 times x minus 2 all over, I know this is a lot of writing, x plus 2, x minus 2. All right, we're getting there. One fraction on the left, one fraction on the right with the common denominator. So now let's eliminate that common denominator by multiplying both sides by that common denominator. Yikes, I'm going to run out of room here, but I'll squish it in. X minus 2, x plus 2. All right, and then the whole point of multiplying by that common denominator is just to completely eliminate it. So we bring this down to the equation 11x minus 2 equals 2 times x plus 2 times x minus 2. All right, you might look at that and be like, what do I do with this? All right, don't forget chapter 8. Chapter 8 is solving a quadratic. This is actually a quadratic equation in disguise. To solve for x, we're going to eliminate the parentheses, look at our terms, and decide on a plan of action. So I'm going to leave the 11x minus 2, just let it mind its own business over here. I'm actually going to multiply these together first. Notice they're conjugate expressions, so I know that this is just going to be x squared minus 4, but let's just confirm that. The product of the first is x squared. The outers is minus 2x. The inners is plus 2x. And the minus 4. So those just cancel. So that's really just 2 times x squared minus 4. So we're at 11x minus 2 equals 2x squared minus 8. So what are we going to do here? Well, I suggest anytime you run into a problem that has x squared, it's a quadratic equation, I suggest setting it equal to 0 and then decide what we're going to do from there. I want my coefficient in front of x squared to be positive, so I'm going to bring the 11x and the minus 2 over to the right. So I'm going to subtract 11x and add 2 to both sides. And that gets me to 0 equals 2x squared. I'm going to put my minus 11x in the middle, and then negative 8 plus 2 is minus 6. All right, so your skills from chapter 6 and your skills from chapter 8 definitely come into play into this section. 9.6 is not an easy section. You have a couple weeks to work on this. I'm posting it nice and early so you guys will get busy and practice. This is a big chunk of your material. It's accumulating everything, so we really want to practice this. So this is what we are down to. Quadratic equation. We have 3 methods of solving a quadratic equation. So we turned this, which didn't look all that painful, rational equation, into a not so easy quadratic equation. How do we solve quadratic equations? 1, factoring. 2, completing the square and using the square root property. Or 3, the quadratic equation. You're welcome to use the quadratic equation here, or this does factor. And I'll give you a hint. If you do this correctly, most of these will factor nicely because the point of this problem is solving the rational equation, so they're not going to give you quadratic equations that are really unkind. So 2x squared, this would have to be 2x and x. I need negative 11 in the middle. I have 6, so I can do 6 and 1 or 2 and 3. So take a minute and think about it. I believe this 6 is going to go here and the 1 is going to be here because 12 and 1 can give me negative 11. I make that negative 6, positive 1. So let's just double check. Product of the first, 2x squared. Product of the last, negative 6. Inners and outers, 1x minus 12x, negative 11x. Right, but remember we're solving for x. So 2x plus 1 equals 0, or x equals negative 1/2, or x minus 6 equals 0, x equals 6. Are they restricted values? So now I gotta go all the way back. Well, our restricted values were 2 and negative 2 right here. So neither one of these are restricted values. Yep. So therefore, they are both solutions. And you may get more than one solution to a rational expression. X equals negative 1/2, and 6 is your other solution. So again, I challenge you, go put these back into the original and check. I think I have just one more problem for you. There are word problems in this section, but this is a long lecture, so I'm going to do all the mechanical stuff, and then we're going to do the part 2 lecture will be your problem solving. That's it. Can you check? Plug them back into the original equation, plug them back in here, put 6 in here and 6 in here, and then do 5/4 over 6/8. Does that equal 2? It's a little bit trickier with negative 1/2, but I know you can do it. All right, one more problem. And then I'll end this part 1, and there'll be a 9.6 part 2, so make sure you look out for it, okay? All right, 4 over x plus 2, plus. I'm going to turn this 3 into 3 over 1, so I see my rational expressions. X minus 3. So my factors, that one has x plus 2, that just has 1, and that has x minus 3. So this guy needs the x minus 3. This denominator needs both the x plus 2 and the x minus 3. And that one's going to need the x plus 2. So this one's just missing x minus 3, because there's always a 1, it's understood to be there. This is missing both the x plus 2 and the x minus 3. So these can get a little hairy, but you have all the skills to do this. So this one's just missing the x plus 2. So you can see that we're introducing a lot here. All right, my common denominator is x plus 2 times x minus 3. This one now has x plus 2 and x minus 3. Don't go canceling those off, because we just put them in there for the purpose of every one of those rational expressions having the same denominator. So now let's create the new left numerator. We distribute numerators, but we're going to leave my denominators nice and factored. 3 times, well, I'm going to leave the 3, and then I'm going to FOIL this. That's going to be x squared. My outers is going to be negative 3x. My inners will be plus 2x, so that will be minus an x, minus 6. So we have to distribute numerators because we're going to combine like terms, but just leave the denominators factored so we can identify our restricted values. Well, 3x times x plus 2 is 3x squared plus 6x. And I'm just going to put the x plus 2 on the right. Nope, on the left. It is on the right, just to make them all look the same. Woo! All right, so now let's distribute that 3. 4x minus 12 all over the common denominator. X plus 2. X minus 3 plus 3x squared minus 3x minus 18 all over the common denominator. X plus 2, x minus 3 equals 3x squared plus 6x all over x plus 2. Now before we go too far, let's just identify our restricted values. I mean, you can do it at the end, but your restricted values, you can look at the common denominator, or you can go up and look at each denominator individually, but do it before you simplify or eliminate the denominators, the restricted values. X cannot be negative 2 or 3. So negative 2 would make this factor 0 or that denominator 0. 3 would make this factor 0 or that denominator 0. All right, so now we have common denominators across the board. Let's add these two numerators and keep the common denominator on the left. And I'm just going to go straight forward. There's only one x squared term, so that's going to be 3x squareds. I have 4x's plus negative 3x, so it's going to be plus 1x. And negative 12 minus 18 is going to be negative 30 equals 3x squared plus 6x all over x plus 2 times x minus 3. All right, so now I have one fraction on the left, one fraction on the right with the same denominator. I'm pretty psyched. So I'm going to, instead of rewriting this whole thing, I'm just going to squish it right in here. I'm going to multiply both sides by the common denominator, x plus 2, x minus 3. Right. And then they're just going to cross off. So we land up solving this quadratic equation, 3x squared plus x minus 30 equals 3x squared plus 6x. All right, so if you think ahead a little bit, this isn't all that terrible, keeping in mind our restrictive values. So we have 3x squared on the left and on the right. Where when we subtract 3x squared, if we subtract that one or this one, they're actually going to cancel out. So this quadratic equation isn't even going to be quadratic in the end anyway. So I'm going to move this 6x over to this side. Actually, I'm going to move it over. Yeah, let's move it over. Anyway, let's subtract 3x squared from both sides, and those are just going to cancel it out. I'm going to subtract 6x from both sides, right? So then my left side just becomes, well, x minus 6x is negative 5x minus 30 equals, well, 3x squared plus 6x minus 3x minus 6x is just 0. Let's add the 30 to both sides. Negative 5x equals 30. Let's divide out the negative 5. X equals negative 6. So if this equation has a solution, it's negative 6. As long as it's not a restricted value, we go back and look. Restricted value, negative 2 and 3, not a restricted value. So we are really excited. Therefore, the only solution is x equals negative 6. We can go back there and check. This one actually we can check. Let's check this one. Remember, check in the original. I'm going to put negative 6 wherever I see x. 4 over negative 6 plus 2 plus 3. Does that equal 3 times negative 6 all over negative 6 minus 3? Let's see that it works. 4 over negative 4 plus 3 equals negative 18. 3 times negative 6 is negative 18. Negative 6 minus 3 is negative 9. Negative 1 plus 3 on the left. We have 2 on the right. 2 equals 2. Woohoo! And that would be the only solution. So my only solution, x equals negative 6. All right, so remember, this is just the first half of 9.6. So what you can do, I'm going to wait to post the second section. I will do 9.6 part 2 probably tomorrow. So to do, but feel free to read 9.6. Exercises 9 to 65 odd. Those are all just mechanical or every other odd. The more problems you do, the better you're going to be at this. Right? Alex. All right, we haven't done any of the word problems, so we will get to the word problems in part 2. But Alex, for, let's see, so for 422, you want to be at 33% plus. or 5+ hours. For 29, you want to be at 66% or 5+ hours. But then don't forget, 2 weeks from this Thursday, on the 5th, you have your Chapter 9 test. So you want to be at 100%. Exam number 4. This is not your final exam. You still have a cumulative final exam. Exam number 4, Chapter 9 on 5/5. All right, kids, make sure you check Blackboard for your Zoom hours, and I will catch up with you really soon. See ya.